Okay, now that we've discussed some of the broader concepts in Python and programming languages in general, let's talk about some syntax to get you started in Python. First, when you're writing a programming language, it's really helpful to know how to label and access pieces of data. When we do that, we're declaring and using variables. A variable in Python is declared by naming your variable. In this case, we're naming a variable x, and then assigning it a value. Here we have an integer called x that we're assigning the value 1, 2, 3, 4. We can also assign the value y to a boolean called true, and we can assign the value z to an integer 4. Now in Python, our variable names should be in all lowercase letters with words separated by underscores. So in some languages, you might name your variable like this. This is called camel case because it has a big letter at the beginning of each word. In Python, instead, we use this. This is called snake case, colloquially. The only exception is when we're writing constants, which are variables that we want to indicate to somebody else who might be reading our program should never change. In Python, we try to name constants with all uppercase characters with the words still separated by an underscore. So you can see an example of that right there with constant name. Now, what I've shown you so far is integers and a boolean, but we can assign any expression to a variable. So, for example, if we say that we want var to be equal to the value of x plus z, we can run that, and the result that we're going to get is the sum of x, which is 1,234, and z, which is 4. So you add those together, and you get 1238. One thing to note about the Jupyter Notebook is that each time you run a cell, the value that's going to appear here is going to be how Python evaluates the last line in your cell. In this case, var. Okay, so that's how we assign variables. Now, one thing you're going to have noticed is that the only way that we know what kind of variable any of these are is by looking at the initial value. We said that these were integers and that this was a boolean. Integers and booleans are both types in Python. Python has a number of different types, including integers, doubles, booleans, strings, lists, tuples, and dictionaries. We're going to talk about all of those in due time. But in the meantime, what's important to know is that in Python, we don't have to specify the type for the variable when we are assigning it. This is because Python is what's called a dynamically typed language. It automatically infers the variable types at runtime. There are other languages that do this, for example, Ruby. Now, lots of programming languages don't do this, like Java or Kotlin or C. Those are statically typed languages. They require the programmer to specify the type of each variable when that variable is declared, and those types are checked at compile time, when it ensures that the program is written correctly to be run. Now, for example, in Java, we would need to declare the variable x from above as an int to indicate this is supposed to be an integer. Now, at any point while you are running or using a Python program, you can determine the inferred type of a variable by using the type function. So you can see an example of this here. We are initializing a variable called birdcall with a string, Polly want a cracker. So now to figure out what type birdcall is, we can say that we want the type of birdcall and str is printed out. So that way we know that Python has inferred that this is a string. Now type is one of Python's built-in functions. The Python interpreter has a number of functions and types built into it that are always available to us to use at any time. Now, in this chart, we can see what all of them are. We won't go over all of these, but it's helpful to know that when you're looking for whether you can do something in Python or not, you always have the option of checking out the Python documentation to make sure that you're doing what you intend, or to find out how Python suggests that you implement something. You can find the documentation for Python at docs.python.org. And you can even specify at that site which version of Python you're using to get the appropriate documentation. Now, let's take a look at some of these built-in functions to get an idea of what they might do. Abs gives you the absolute value of a positive or a negative number. Float allows you to convert one type into another. In this case, to attempt to convert a variable into a float, that is a number that has some decimal places on it. Let's look at one more. Let's do max. So max is a built-in function that determines the maximum within a collection of items, the biggest within a collection of items. So that covers our built-in functions. Now let's talk a little bit about what the core data types are in Python. We won't go over all of these in detail today, but it's helpful for you to understand that they exist so that you'll have heard the terms before when we go over them later. So first we have the numeric types, int and float, which we've already talked about, as well as complex numbers, which allows us to mix real and imaginary numbers. We also have sequence types, so that's a string like we've seen before, as well as lists or tuples. So we'll talk about those in the future. Then you have your Boolean for true and false, and then you have a set type, which we'll also talk about in the future, and mapping types like the dictionary, abbreviated to dict in the Python language. Let's start with those numeric types we talked about before. You can see some examples of integers here. They look similar to what we've discussed before. And then we have floating point numbers, which, like I mentioned, allows you to access decimals. You then also have the option in Python 3 and up to do octal, hex, and binary literals like this. Now those were done differently in earlier versions of Python, which is why you see this fourth row here, but we won't concern ourselves with that because the 2 and below versions of Python are deprecated and pretty old at this point. And then finally, we have our complex number literals, mixing real and imaginary numbers. Now, you can also import other specialized numeric types like fraction or decimal from the standard library. We're going to talk about importing things a little bit later, but they're not available to you automatically the way that, for example, an int or a float are. Now, we can also convert numeric types from one type or another, and we saw an example of this when we were talking about built-in functions earlier. For example, we can convert things to an int, to a float, or to a complex from one numeric type to another. We'll see examples of this as we're practicing. So, suppose that we have an integer called x. It amounts to 235. We can convert that integer into a float by using the built-in float function and passing x to it. So you can see here now that we have 235.0. Now, numeric expressions allow us to use operators on them. A lot of the operators are mathematical functions that you'll be familiar with, like adding, or subtracting, or multiplying, or dividing. Now let's look at some of the others. This double division symbol gives you the floored quotient of x and y. That is, when you divide one number by another and it doesn't divide evenly, this is the number that it divides into, not the remainder. You can get the remainder with the modulo function, which is this percentage symbol that we see here. We can make a number negative with the negative symbol. We can make a number positive with the plus symbol. We can get the absolute value, as we discussed, convert things to integers, floats, and complex numbers. We can get the conjugate of a complex number by calling the conjugate method on it. We also have the divmod, power, and I would generally use this rather than the power function, but they do the same thing. So here, if you want to say that x is supposed to be to the power of y, that is multiplied by itself y times, you can say pow, or you can use this double asterisk. Okay, now we've discussed that you can convert different numeric types to different other numeric types, but in certain circumstances, Python will also do this automatically for you. So let's talk about arithmetic conversion. We can do arithmetic with mixed types of numerics. What Python's going to do if you add two different types of numerics together is it's going to convert the different things that you were trying to add or multiply or divide or whatever up to the most complicated type. So let me show you an example of this. Here we have an integer 34 and a float 3.2. If we want to add those things together, what's going to happen is 34 is going to be converted up to a float, and 3.2 is going to be left as a float. The result is then going to be a float. Now, the order of complexity goes integers, then floating point numbers, and then complex numbers, with integers being the simplest and complex numbers being the most, well, complex. So we can see another example of this here. Now it's worth noting that here, the operation that happens in parenthesis is going to happen first. So here we're going to add 3 and 5 and get an integer of 8. We're then going to subtract a float of 4.0. So 8 will be converted into a float of 8.0, and our result should be 4.0. Now let's talk about Booleans. The values that represent Booleans are true and false. In some languages, these are not capitalized. In Python, they are. Now, there are operators that we can use on Booleans, just like there are operators that we can use on numerics. So, here we can see an example of how operators might return us Booleans. If you have two integers and you want to determine whether one is greater than another, you can use the greater than symbol. And if x is greater than y, this is going to return true. If x is less than y, it will return false. You have the same thing for the less than operator. Now, you can also determine the equality of two objects with equals equals like this. Recall that earlier we used a single equals to assign a value to a variable. 1 equals is for assignment, 2 equals is for determining equality. It's very important and an easy mistake to make, so I want you to remember that. Okay? Now you can do equality on all different types, not just numeric types. It's worth noting that the double equals gives you value equality. So if you have two integers that both point to a value of 4, those are going to be considered equal, even if they are stored in different places in memory. We'll talk later about how you can make sure the two objects are in fact the same object. But for value equality, we use double equals. So, if we want to make sure that two things are not equal, then we can use the bang equals symbol like this, exclamation point with an equals after it. It's also worth noting that you can use a not keyword, which we'll talk about in a second. We can make sure that things are, that x is greater than or equal to y, or we can check if x is less than or equal to y. So here we see an example, an expression that says 3 is less than or equal to 12. Do you think that this will return true or false? Let's see. That's true, because 3 is less than 12. Now it's worth noting that because this is less than or equal to, 12 is less than or equal to 12 would also return true, but 13 is less than or equal to 12 would return false. So, how about this one? Is 5 equal to 7? Of course it isn't. But if we were to change this to 7, then this would return true. So now, I mentioned that we would come back to not. We'll do that here, in the logical operators. So, if we want to determine whether two separate things are both true, then we can use the AND operator. Many programming languages do this with an ampersand, like this. In Python, we use the word AND. Now, if we want to determine that at least one of several things is true, then we can use the OR operator. Once again, many programming languages use this symbol, sometimes known as pipes. In Python, canonically we use the OR keyword. Finally, we have the NOT keyword. Many programming languages use the bang symbol for this, which looks like an exclamation point. In Python, canonically, we use the word not. The idea is to have one common format in Python to ensure that our programs stay legible to other Pythonistas. Okay, so let's look at an example of one of these logical operators. Here we have 3 is less than or equal to 12, which we know is true, and 4 is greater than or equal to 4. What do you think this will return? It returns true, because both of these things are true. Now, let's take a look at the not operator. We've set B here to false. So what should not be? True, because not flips the value of the Boolean. Now it's worth noting that the and or operators short circuit. Now, what does that mean? Well, here's what it means. We'll use this little function called doIGetRun to illustrate this concept. It's going to print out I got run if the function gets run. Now let's take a look here. We have true or doIGetRun. Now recall that when we are doing the or operator, we want to ensure that at least one of the conditionals is true. Now, we know that the very first conditional is true. So we don't have to run any of the others to know that the value of this thing is going to be true. And for that reason, we get true back, but doIGetRun never runs. Now, let's look at the second example. Here, we have the or operator again, but the first conditional is false. Python evaluates these conditionals left to right. So it starts with the leftmost one, false. Okay, well so far we haven't established that at least one of our conditionals is true. So we need to move on to the next one and evaluate that one. In this case, doIGetRun will get run, as you can see. Now, suppose that instead of saying or here, we said and. Do you think this will run? Because here's the thing. And is there to ensure that all of the conditionals are true. And when we start at the leftmost conditional, we already know that that's not the case. So there's no need to run doIGetRun. Instead, our result is just false. Now, we've talked a little bit about our various numeric types. We've talked a little bit about Booleans and a tiny bit about strings. There is one more type that I want to make you aware of before we end our most basic syntax overview. And that's the none type. Now, most programming languages have a value that represents the absence of a value. And that is what none is for Python. You may have heard about this in other programming languages, because in Java or C or Kotlin or SQL, the absence of a value is represented with null. And in Ruby, Swift, and Lisp, it's represented with nil. Python, none. And you can see that right here. When we set x to none, we print x, we're going to get none there. But if you were to try to call any method on it, you're going to get a type error. An object of type none type doesn't have this method. So, when you see the error message, object of type none type has no blah blah blah, that tells you that whatever you're trying to call blah 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 on is none. And if it's not supposed to be none, then you want to check your program to figure out what went wrong.